hydrogen bond, a bond that has a very strong significance in biological science, is hydrogen bond. So what happens is, from the name you can already tell that hydrogen would always be present when there is hydrogen bond formation. So when hydrogen forms bonds with any other highly electronegative elements such as nitrogen, fluorine, oxygen, then this type of bond is observed. So what happens is, these elements, they are called highly electronegative. What does that mean? Well, when something is highly electronegative, that means it will pull the shared electron towards itself more than its partner. So I have taken the example, very popular example of hydrogen bond is water. So what happens is, in water, the oxygen has two pairs of lone electrons, two lone pair electrons on either side, and with the two electrons it forms a covalent bond with hydrogen on two sides. But since oxygen is highly electronegative, so it pulls the shared electron cloud towards itself strongly than the hydrogen, and that's why the structure of water molecule is written in a bent form. So you see the hydrogen has a greater pull on the shared electron, and in doing so what happens is the highly electronegative element oxygen becomes a partial negative charge and the hydrogen becomes a partial positive charge. Well, the term partial is used because they don't get entirely charged particles like in ionic compounds, but because of this electronegativity difference, the hydrogen, which is less electronegative than oxygen, would always have a positive charge, but the higher electronegative element will always develop a partial negative charge. So this is all about hydrogen bond, how the hydrogen bond is present in the water molecule. So what happens when we have, let's say, a cup of water, this is a separate water molecule, this is another water molecule, and so on. So we see from this structure that the hydrogen bond present in water is between the adjacent water molecule, but not within itself. And so to show the opposite charge hydrogen bond attraction of one oxygen in water molecule, one water molecule with hydrogen atom of another water molecule, again this oxygen atom has with its partial negative charge is attracted to this partial positive charge of the hydrogen through a hydrogen bond, and so on. And the hydrogen bond therefore is represented by these dots, and this is how the hydrogen bond is present in water. Types of hydrogen bonds. So just like a little bit ago, I show you that in water molecules the hydrogen bond is present not in the water molecules itself, but with a neighboring water molecule. So depending on the type of water, the hydrogen bonds formed within the molecule or with a neighboring or separate molecule, it's called, the hydrogen bond are classified into intermolecular and intramolecular. So from the word inter, we know that two different entities, and intra means within the same entity. So from the structure of hydrochloric acid, the same goes for water and hydrofluoric acid and so on, that the hydrogen bond is formed between the neighboring separate hydrochloric acid molecule. Here the chlorine of the hydrochloric acid has formed a hydrogen bond with the neighboring hydrogen atom of the hydrochloric acid, and so on. But in some cases it is seen that in case of the intramolecular structure, intramolecular hydrogen bond, what happens here, I have taken the example of nitrophenol, which is another organic compound. So here we see that this is how the chemical structure looks like, and here we see that within a single molecule the hydrogen and the oxygen has developed hydrogen bond between them. So this is not observed clearly in hydrochloric acid. So on the basis of where the hydrogen bond formation is taking place, the hydrogen bond has been classified as inter and intramolecular. Inter, it's a very obvious from its name, when it's two separate molecules, just like here the separate this molecule is not forming hydrogen bond within itself but another molecule, and so on. This is inter, but when it's intra, so the bond is forming within the compound itself, and here we see in case of nitrophenol there is a hydrogen bond between the oxygen and hydrogen. So this is all about the types of hydrogen bond.